Hi, everybody. Thanks for hanging out with us today near the end of the Dev Summit here. So just a quick intro. I'm Chris Andrews. I'm the 3D product manager for Esri. I cover a lot of stuff these days. I do play with code and things like that when I have time. But most of the time, I'm working with customers and partners like Autodesk and all kinds of stuff like that. This is Javier. You want to introduce yourself?
Sure. My name is Javier. I actually work in the Zurich office in Switzerland, product engineer lead for the web 3D technology, so JavaScript API and Scene Viewer. JavaScript API is included also in Web AppBuilder and story maps. So all the web 3D stuff that you see, we're working in Switzerland and gather requirements and work with the developer team. And my background is software development, so I still can read some code.
Yeah. All right, so this talk was originally designed for the FedGIS audience, where there are certain folks who ask about WebGL globes. And so that's where the title comes from. This talk is intended as a high-level overview of some of Esri's capabilities. And then, so I'm going to try to go somewhat quickly. And then Javier is going to run through some demos and examples of what you can do in Esri. So with that, I'll just get started. Oops, yeah, thanks. All right, so this is not necessarily a programming class. The goal is to help you learn a little bit about technology that impacts your ability to deliver maps and visualizations throughout really large organizations. Some technology will be mentioned, of course, and then some code examples may be shown as well. Key takeaways are that WebGL enables zero plugin mapping experiences in browsers. Esri has a WebGL capability for 3D and 2D. With Esri WebGL tools, you can customize and integrate 3D maps into your workflows and applications. I've actually heard about some really great examples of this here. And then our WebGL experiences allow you to take advantage of your investment in other ArcGIS services to be able to be used in 3D. So WebGL is a 3D API standard for web-based 3D that's been around since about 2011. It works with OpenGL. It's basically OpenGL in a browser. It can work in Chrome, Safari, Firefox, Edge, and there's constantly increasing support for it. iOS and Android mobile browsers do support WebGL, and the support has increased quickly enough that these guys have felt comfortable starting to roll out mobile support in the Scene Viewer. It's used in over billions of devices and browsers at this point. There are many different geospatial flavors. We have had one since 2013. You will see there are many different spatial flavors like Tinkercad and all kinds of stuff that take advantage of WebGL that are not necessarily GIS. WebGL is basically an ECMAScript library for doing graphics operations and processing graphics and rendering them into a canvas. There aren't really native file formats in WebGL, but we are increasingly seeing GLTF as an open standard from the Kronos group that is being adopted as a common payload format for WebGL experiences. It can be combined with other JavaScript stuff, and it basically allows direct drawing on a canvas with primitives, and it's increasing tremendously in capability over the last few years. WebGL enables you to have really great browser-based mapping apps with no plugin. And we've seen some experiments from us over the last few years on like Firefly animations in a web browser, and you've seen the fantastic sketch-like lines capabilities and shading, illumination, all kinds of stuff that these guys are doing in the Scene Viewer and the JavaScript API. They're building on WebGL capabilities to do that. The upside of using WebGL is there's no plugin. We're still seeing 3D plugins for the browser in the market, especially in Asia and in a few other places, parts of the world. It's got extremely broad community support. It's open standards based. There is greater variation in per platform support, but that's gradually decreasing, except for the fact that there will be a new WebGL version in a couple of years or a year or so, and that is going to reintroduce kind of browser heterogeneity. And then it requires JavaScript programming to really take advantage of it, and that's not really a negative, but it is a programming concept.
One exception is I11 is still
okay. That's a good point. Yeah.
Chrome, Firefox, Safari, and Edge, actually, they're pretty good in their supported capabilities, but I11 is still pretty limited. So that's one exception.
Nice. Good. Okay. So, like I said, I originally put this talk together for the Fed GIS audience. So in the federal community, they often don't pay attention to who the brand is on the technology. They just talk about what it is. So you'll hear them talk about 3D Globe or WebGL Globe experiences a lot. Some of our users need a WebGL Globe experience in those environments because it basically is delivering a zero plugin version of what Google Earth's plugin used to do. And that plugin isn't available anymore. And so now they're looking at alternatives, and they have been for the last couple of years, and are in some cases still building alternatives to that Google Earth plugin experience that was available for years. The GIS market has definitely significantly moved to 3D. I think especially outside of kind of the traditional Esri customer base, the GIS market pretty much predominantly expects 3D. And if you look at adjacent new markets like high-def mapping and other markets that are working with kind of modern technologies and data collection capabilities, they're almost all 3D first. Globe-based communication, so one of the things that we've had to work through in some cases is, why do people use globes? Well, globes tend to be used in environments where non-highly technical people are looking at data scattered across large areas of the globe, and they need to understand what the relative position of those things is with respect to each other. And they're unlikely to understand map coordinates. But can we handle different map coordinate systems? Well, yes, of course we can. So Esri customers can create services in WGS 84, WebMercator, and other Cartesian and non-Cartesian CSs, and then they can use them in our WebGL experiences. When you're in global 3D, I just want to clarify, sometimes there's a little question about this. Esri actually always displays data in WGS 84 GCS, even if the incoming data are stored in WebMercator. So what you're seeing is always WGS 84 GCS. Let's see, what else do I want to hear? Yep, we can display 2D web layers and web maps using WebGL. You can switch back and forth between 2D and 3D. This is possibly the first show where I haven't gotten that question. But we have a lot of examples of people doing that now. It's typically done through customization. And you can navigate underground in local scenes, so the Cartesian and other planar scenes today. And I think you guys are trying to make that happen for later this year or early next.
And global scenes, yes.
In global scenes, right. WebGL clients, I'll simply say they're just part of the WebGIS infrastructure, right? The whole value of Esri is you can put a whole bunch of different layer types in this middle cloudy thing, whether it's Enterprise or ArcGIS Online or a bunch of all of the above. And then you can access those data layers in a variety of clients. And we'll see new types of client experiences starting to come out in this year and the next few years. My job is to try to promote 3D as a core capability everywhere. GIS is 3D. I don't know how it happened, but it's great to see that they've got GIS is 3D up on the kiosk this year. The 3D, it takes advantage of the same services-based architecture you guys have heard of from Esri for a few years. There are some new clients and experiences around 3D, some new data types as well. And this is generally the area that I'm focused around. Part of the 3D effort has been the adoption and in some cases the creation of new standards in the GIS space. We are doing more with things like KML and even ZLAS, and actually, I don't know if anybody noticed, but you can go directly from LAS to I3S point clouds now. I3S is a new OGC community standard that was submitted by us for streaming large amounts of 3D content. And then we have things like LURC and LEPCC that are compression patterns for raster data that are required for really heavy, really large like elevation data that are streamed into 3D experiences. If you're talking about 3D with us, you'll hear Javier or myself refer to things like web scenes and mobile scene packages, although actually we're going to change the name to scene packages, and scene layers. Web scenes are basically a container for a bunch of layers, some environment information, maybe some slides, table of contents order, all that kind of stuff. Basically, it's a 3D map. scene layers are actually a special kind of 3D cached content that can be extremely large but perform very fast when streamed down from the cloud or an enterprise to a browser. And then scene packages, mobile scene packages are something we're planning to release later this year, where you basically can roll up all the content in a web scene, take it offline, or even take it offline, move it to someplace else, and then redeploy it to another server. i3s, I'm not going to belabor this one. We rolled out i3s a couple of years ago and then submitted it to OGC as part of the community standard process. It's now a standard. We're seeing pretty great adoption from a variety of vendors, and we're starting to see it appear in like government RFPs, which is fantastic. There are a variety of different profiles of i3s. You can see this integrated mesh stuff that Brycon has started to pump out in many of our stage demos at the UCs. And then we've got just an expanding list of layer types and layer capability. There's even a full open source stack, server, client, and data production pipeline that's been created that can consume and create i3s by this Czech company, Malone. All right, so our complete JavaScript stack that's based and uses a lot of the things I just talked about is one thing, even if we often talk about it piecemeal. So we have the ArcGIS API for JavaScript, which is 2D and 3D. We have widgets that are built on top of that. We have the scene viewer and the map viewer. Then on top of those, you can see we have other experiences such as story maps and web app builder. There are more widgets that are often built to work with those. And then we have other tools like GeoPlanner, 3D, Ops Dashboard, Hub, the future ArcGIS Urban, and other tools that are all additional value add or tailored experiences on top of this stack. So the whole reason that we put this original talk together was to try to bring this all into one discussion to give a starter audience an overview that this is all related capability on top of JavaScript WebGL capability that Esri has been building up over the last few years. Okay, I'm not going to go into scene viewer capabilities. You guys can have these slides later. I want to let Javier start his demo. You guys have heard of Web App Builder and Story Maps. Those are part of the stack. There are a whole bunch of JavaScript API customizations that you can do. The silly thing on the lower right is me playing around with an ISS endpoint out in the cloud somewhere, where I was able to just ping the ISS location every 10 seconds, plot a point, and relocate the map to look at the point. It took me 15 minutes to go in and hack that out in the sandbox. In some ways, there is some new stuff you can do. I used to be in enterprise integration though, and there's a lot of classic 2D GIS mapping capabilities you can now implement in 3D with the JavaScript API. All right, so I'm going to turn that over to Javier. Go ahead.
All right, and like Chris said, this is not really a JavaScript class or WebGL class. Actually, there is another session today at 5:30 if you're interested in extending the WebGL capabilities. It's advanced features with the 3D JavaScript API. I really recommend it because my colleague, the senior developer in Zurich, is presenting and he has some really awesome demos that he's built. But let me go through some of the examples I had prepared for you today. So I just want to go first and talk about some of the applications that we built as a demo application in a vertical use case. In this case, this is an application for planning, for analyzing the usage of building by floor. So typically when urban planners look at a city and want to analyze the usage, they look at a parcel, and a parcel is commercial or residential. The problem with that is in many cases you have a commercial floor and then residential floors on top, or even offices, or mixed, a bunch of different things. So this application brings those different usages mixed together. So here what you see is the scene layer. It's actually a demo data set. We implemented this for the entire city of Zurich, but this is just a small sample data set. And we can see different different usages here: residential, office. We can also see distribution by area of the different floors. So, for example, this is a pretty common area. We can also select one of the buildings and get just the statistics for one of them. This kind of customizations like this. This is all built with a out-of-the-box public API, JavaScript API. So you can all build the same yourself. We also have filtering capabilities. So if you want to see the usage just by the bottom floor, that's a typical use case. You want to see that actually many of these are actually storage or retail, that's good. We want to avoid, for example, in Zurich, there's a project to avoid residential in the bottom floors. We want to keep the neighborhoods, we call it walkable cities or engaging cities. So we want to have commercial usage on the bottom floor. So that's a typical use case for planners. So that's built with the JS API. We use renders, we use transparency, we use different colors, we use filtering, and we combine all these capabilities to create this focus app. Another app that we built to showcase some of the features of the API is this Manhattan Skyscraper Explorer. It's actually using this very similar features that we saw before with different purpose. This is more of a, let's take a look at what kind of buildings we have in New York. And the capabilities here is, or the main point of this app is to explore the different skyscrapers in Manhattan over time. So here we can see a progression of the buildings by construction year over time. And then in the vertical axis, we see the height of the building. We see, for example, I think this was the Great Recession over here, so not so much construction going on. We see some picking up here, and then the recent recession in the last few years. So we see that progression of buildings, and also how, at the beginning of the century, the buildings were much lower. You can also select some of the buildings and then get more information. So what we see here is actually using an external API. So this is a way of an example on how to integrate the JS API with external APIs. This is a very common use case. You have information about your building, but actually your information about is it available? Is it available for sale, or is it available for rent? You have it in a different service. So here what we're doing is querying Wikipedia and Flickr for photos based on the building name. And then we obtain that information and we present it on the same application. More things that we can do is filter by a specific range of time. So if we want to see only the older buildings in the city, we can do this, and then only the beginning of the century is symbolized. And what I find really, really cool is filtering by height of the building. So if you're interested only in the taller buildings, you can interactively apply a filter and then get only the taller buildings displayed. And notice this is really not a video, it's happening in the browser, in JavaScript, how fast buildings come in and out. This is actually implementing a definition expression on the buildings. Definition expression that you know from ArcMap and from feature layers, it's the same concept. So we apply definition expression on the height field, and if buildings are taller than 300 feet or shorter than 1,000 feet, then now they display. So you can get this kind of visualization. Something that you already saw quickly is the highlight. And I just want to make a small mention on the highlight. Highlight is a feature we released, actually, not this guy. Sorry. Well, let's just use that one. So highlight is a feature that we implemented in the last release of the API, or last year in the release of the API. And it's really cool because what you can see is the highlight shines through other buildings. So when you look at it from behind another building, you can still see that feature is highlighted. Right? You can still see the 3D shape of the highlight shining through the other buildings. You can use the API to change the color of the highlight, the intensity, the transparency. You have multiple options to implement in the API. These apps, by the way, I don't know if you noticed, these are in GitHub, so you can go and take a look at the code yourself, both of them. We also have blogs in the Esri blog explaining how they're built. And another GitHub app that we're going to put out coming up, I presented it in the plenary very briefly, but this is also a really cool app where we see the names of hiking trails in the Swiss National Park, also elevated with callouts, another feature of the JS API. You can also filter them, again with definition expression, same concepts, nothing too new. And you can filter them by walk times, for example. Select any of the trails and get more information. This is actually using a really interesting feature of the API, which is the elevation query. With the elevation query, you can use the Esri provided world elevation service and obtain samples of the elevation of the ground to build profiles like this, or to calculate the slope, or you name it. You can use that elevation for your own purposes, and you don't have to provide that data. That data comes from the Esri provided world elevation service. You just have to go into JavaScript and say, I want the elevation for that point or for that line, and then you can query that on the client and use it. Another example of integrating with other APIs, again, Flickr API, but now it's actually represented in the map. So those photos that are coming from Flickr, we're adding as points, as an icon symbology, and now we display them inside the map. And they're elevated in 3D again. And now these are kind of the simple apps, so basic public API. Everyone really can implement these kind of applications without a lot of programming knowledge. But let me go a bit deeper into WebGL. So the API supports multiple layers, multiple symbology types. Actually now in the next release, we're actually going to support line measurement and area measurement. However, you might want to add more than what we have. And if you're very good with OpenGL and 3D programming, you can create really cool visualizations like this, for example. Our colleague implemented this visualization dashboard for the traffic in New York. This is real-time traffic. Oh, sorry. Sorry about that. This is real-time traffic in New York. And what he implemented on top of our engine is this visualization of traffic. What you can see is these cars moving. This just represents, it doesn't represent real data, but it gives you the feeling that something is happening, that something is moving. This is a really interesting effect to tell the people that see this map that something is going on, and really catches your attention, right? So if you are interested in going into WebGL, you can do things like this. Also, if you select any of the problematic areas of the traffic in New York, which apparently there are many, we get this highlight, this circle that is moving up and down. This is also generated as a custom feature. We don't support this in our API. That is pretty easy to extend to do things like this yourself. Another map that our colleague did, another cool map, is New York crime trends. Here you can see a progression of crime rates in 2015 over the whole year, so from January to December. And here we see the number of incidents every month. So this is March, 19 incidents, April, 13 incidents. And then he plots this in a 3D mesh or 3D surface that is morphing over time. So when he changes from one month to another, he's morphing that mesh with a really nice animation. And with this, you can really get a feeling of what are the hotspots for crime around the area that you have selected. You can select any other area, and we'll do some server calculations for their area, and then start the representation in that new location. Just give it a couple of seconds. So here he's using many tools of the API, like the hit test, representing the icon with callouts, representing a circle with the graphics layer, another circle with the graphics layer. But this surface mesh that you see there, animated, that's extended with WebGL. And how to do that? That's actually using the external render. It's a feature that's in the API. So here's the SDK page where you can learn how to do a lot of cool things with our API. And if you search for samples, that's a good start, for example. You can also search for the API reference where there's a lot of documentation. But if you go in the samples and search for external render, there's a couple. I would recommend you start with Windmills example, because it really has all the steps on how to create shaders, how to create vertex buffers, how to create your own render. So you should start with this, but I don't really have time to go into it. I'm going to show this one quickly. And this is how to integrate Three.js with the Esri JavaScript API through the external renderer. And that's a better sample than Chris did with the ISS tracking, I think, because we actually have the ISS model here in 3D. And this part here, the ISS, it's actually being rendered in Three.js, not in our API. And here I can show you a quick peek. So here we're creating, for example, the external render. We're using Three mesh material, Three.js render. Yeah, I can't really go through the code, but just to show you some of the capabilities of Three.js is something that we actually don't support, and Chris really wants, is this wireframe mode. So if I now turn wireframe true into the Three.js render and reload the sample, now we'll see that the ISS model is actually now rendered, if I don't lose it, it's actually now rendered in wireframe mode. So that's actually rendering in Three.js, like I mentioned, and they have this wireframe mode, and they have a lot of different cool capabilities, 3D cool capabilities, like emission and glow and multiple different things. So if you're familiar with Three.js, this is a good example to get you started on how to integrate it with the API. And that's all the time we had.
Yeah, thanks, Javier.
Sure.
So there's maybe time for one or two questions before we have to turn it over to the BIM guys. Are there any questions? No? All right. Thanks, everybody, for participating. Have a good rest of the show.
Thank you.